So this circle over here, right? So this belongs to the what? This belongs to the YZ plane, right? And then another circle that we can draw. So it will be from here. So 8, this 10, 8.5 is about here. That is the other circle. Okay. So this, the last circle I've drawn, this belongs to our XZ plane. Okay. So this is one possible answer. Okay. Now we look at the other. So anyone, any question with this, right? So that is, so this is not valid. It's outside our what? It's outside our operating limits. Okay. So what is the next possible value now? Okay, so we're going to find the next possible value. Okay, so again, we're going to construct the other Mohr circle. Okay, so I'm not going to focus on the on the minus 20. Okay, because we know that the circle cannot go to the minus 20 region. So I'm just going to construct the positive to shorten time. So this is minus 4, 0, 4, 8, 12, 16, and 20. So normal stress. And then we have our shearing. Okay. So our shear, element rotate clockwise, element rotate anti-clockwise. So this will be minus 4, 8, 12, 4, 8, 12. Then I'm going to sketch out where our limits are. So the circle cannot go beyond here. Our circle cannot go beyond here. And our circle cannot go beyond here. Okay. Then we have our 14 line. And then we have our 8 line. Based on element rotation, we know that over here, this is where my point X is. Okay. And then we know our anchor point. Okay. Our anchor point is over here. This is our point Z. Okay. So we are going to use our minimum or our stress, not principal stress, stress 1. Okay. So I'm going to use this point over here. All right. To join the my point X. Okay, so using the same thing also the rules of the circle, right? So I'm going to copy, I'm going to paste, I'm going to rotate this by 90 degrees, right? So we found where is our stress 1 point. Okay, so if we were to construct this, we're going to draw a dot. Right, so this will be our stress 2 point. Okay, so we're going to find the position of stress 2 point. So I'm going to call this point over here. This will be my alpha, right? So if that's my alpha, based on similar triangles, this angle also be my alpha. Okay, So we try this with using tangent alpha will be equal to what? 8 divided by 246 divided by 6. So alpha is equal to 8 divided by 6. It's equal to 53.13. Let me do the other divided by 6 inverse tangent. It's 53.13. Okay, so therefore we can find stress 2 will be equal to will be equal to 14 minus by tangent minus by 8 tangent 53.13. Okay, so it's 14 minus by, so tangent of, okay, times by 8 is equal to 10.667. No, not 10.6. What am I doing? So tangent 53.13 times by 8. It is 10.66. So stress 2, we get 14 minus a 10.667 is equal to 3.333. Don't really look like 3.333 on my solution. Is it 3.333? 10? Hold on, I'm checking. $14, 26. So I calculate. So alpha, let me check. Okay, so 246. So 2468. So 8 divided by 6. Inverse tangent is 53.13. So this is 8. Okay, so they say, hold on, I think I'm correct. So tangent of 53.13 times 8, 14, 3.333 KSI. I'm a bit concerned is because my stress Y2 when I draw this is not exactly at it can be because of my construction. Let me do it again. Okay, copy, paste, and then I flip this right by 90 degrees. Yeah, the construction looks good. Okay. Okay, so it should be at 3.333. Somehow I'm not getting it. I mean, sorry, based on the construction, I'm getting a 4 down here unless I make a right. I'm getting a stress Y2. I'm getting a 4, which is not 3.333. Hold on, let me check. B. Okay, I think I'm okay. So from here, we can calculate our stress average or center of circle. Okay, which is our stress average. So our stress average will be equal to 20 plus by 3.333 divided by 2. So 20 plus 3.333 divided by 2 is equal to 20 plus by 3.333 equal to 11.666. 11.667. Okay, so 11.667. So 8, 10, 11.667. So there's about from here to here, right? So let me draw a vertical line up. So this is 12. This is 11, 11.667, somewhere around here. Okay. So now we can draw another straight line across. So somewhere around here, about here, this is our Y2. Okay. So that is our Y2 line. So to calculate our Y2 line, right? So we know, right? So the angle, so we know that if this is alpha, this angle is also alpha. This angle over here will be our 2 alpha, right? Right. So if that is our 2 alpha, this angle over here is 180 minus by 2 alpha. Okay, that angle over there, because it's a straight line. So this angle over here is 180 minus 2 alpha. Okay. So from here, we can calculate our Y2.
Excuse me, Gene.
Yep.
Right above point X, should that be 90 minus alpha rather than just alpha?
Say it again.
Right above point X, you have alpha and then alpha again. Should that be alpha and 90 minus alpha?
So this alpha you say is wrong?
I'm just confused as how they're both alpha, because that's 90 degrees. Unless alpha is
it's not the same.
degrees.
It's not the same. I think I used different color. Wait, let me.
Oh, I think I see it now. It's between
Right?
the
Yeah.
X line.
Yeah. So if this so this is alpha also, right? I should have used different colors because this is the same distance, right? And then from here to here, right? This line over here, right? This is 2 alpha.
Yeah, that all makes sense.
Okay. So this is 2 alpha, right? So when that's the case, this angle over here is 180 minus 2 alpha. Okay. So from here, no, I want you to clarify because there's anything that's not clear. Okay, that's good. So stress Y2 will be equal to 11.667 minus, right? Minus by cosine, right? Cosine 120, right? Minus cosine. Do I know the radius of the circle? Yeah, I do know the center of the circle. We know, right? So the radius of the circle, in fact, we have to calculate the radius of the circle first, okay? So by observation, we have to calculate the radius of the circle. So we know the center of the circle, we know stress too. So the radius of the circle will be equal to stress 1 minus by, or which is equal to our stress 1 minus by stress 2 divided by 2, right? So stress 1 is equal to 20 minus 3.333 and then divided by 2. So 20 minus 3.333 divided by 2, the radius of the circle is 8.333, okay, KSI. Right, so to find Y2, we know that this will be equal to 8.333, radius of the circle, and then we have cosine of 180 minus 2 twice the alpha, which is equal to 53.13. Right, close bracket. So this will be equal to 11.667 minus by 8.333 cosine of, so 2 times of 53.13 minus by 180 is equal to 73.74.